Hi everyone. Today I'm going to discuss with you all the Hurwitz stability in control system. It's actually the stability checking method. I'll explain this method with the help of a numerical. So let's start. Okay guys, here I write the question and I'll read it. Using Routh criterion, determine the stability of the system represented by the characteristics equation s raised to 4 plus 8 s cube plus 18 s square plus 16 s plus 5 is equal to 0. Comment on the location of the root. Here, our characteristics equation is s raised to 4 plus 8 s cube plus 18 s square plus 16 s plus 5 is equal to 0. Anyway, I'll write this characteristics equation here and then 8s square plus 16s plus 5 is equal to 0. You have to first do check whether what is the order of the system. Okay, you have to check what's the order of the system. Here, the first order of the system is s raised to 4, right? And 4 is an even number. It's not at all an odd number. 4 is an even number. So you can write all the s raised to the first point or the first number s raised to 4 here. Then the coefficient of s raised to 4 is 1. Then you have to write all the coefficients of the even numbers. How many even numbers are there in the question? S raised to 4, 16 s square and s raised to 0. S raised to 0 means 1. So here it's 5 means 5 into s raised to 0, right? That is 5. So we can write s raised to 4, the coefficients of s raised to 4, coefficient of s raised to 4 is 1. Then the next even number is 18s square. So you have to write the coefficient of s square as 18 here. Then the next number is 5. Then you have to write the next order of the system is s cube. S cube means what? It's an odd number, right? 3 is an odd number. So we can write all the coefficients of odd numbers in this characteristics equation. It's 8 and 16. Then it's over. The characteristics equation is completed, or we write all the coefficients in this the complete characteristics equation. Then we can proceed this by the calculation. The next number should be here we have s raised to 4. Then the next number is s cube. Then the next number should come as s square. Okay, s square. Then how to find the values of s square, or how to find the coefficients of next even number? First, you have to check any series in this number is divisible by any number, is completely divisible by any number. Here, s raised to 4 means 1, 18 and 5. 18 and 5 are not divisible by any number. So we can't proceed it that step. Then s cube means it's 18, 8 and 16. 8 and 16 are divisible by 2, 4 and 8 also. So here I have to divide this s cube by or this numbers by 8. So I get the values are 1 and 2. Okay, I get the values are 1 and 2. Then I'll write it here for s raised to 4 as 1, 18 and 5. Here it is s cube. I'll write this s cube as 1 and 2 for the further proceedings. Okay, for the further proceedings, I need to write these values are 1 and 2. Then we have to find the s square value. S square, how to find the s square value? You have to do first 1 into 18. Okay, 1 into 18 minus 2 into 1. Cross multiply. It's just like the determinant method. In determinant, we have to do like this multiplication minus this multiplication. Here we have to do is 1 into from here to there into this multiplication divided by here. Divided by this number. Divide by this number means what we will get? We'll get it as 18 minus 2 by 1 is 16, right? at 16. So I'll write the value as 16 there in the place of s square. Then we need to find the next number here. For that, 1 into 5. Okay. 1 into 5 minus any number here? No. So we can assign it as 0. 0 into 1 divided by again the first column number is 1. Okay, that is 1 into 5 minus 0 into 1 is 0. That is 1 into 5 by 1 is 5. Is 5. So s square is 16 and 5, and 16 and 5 are not divisible by a particular number. So we have to further proceed the value as s raised to 1. Okay, s raised to 1. Then how to find the values of s raised to 1? You have to multiply these numbers. 16 into 2 minus 1 into 5. I'll do it here. 16 into 2 minus 5 into 1 divided by 16. That is 32 minus 5 by 16, which is 27 by 16. 20 for us 1.7. Then we have no numbers right here. So we can further proceed it with s raised to 0. Proceed it with s raised to 0. In the case of s raised to 0, again the same procedure as before. So we can do it with 1.7 into 5 minus 0 into 16 divided by 1.7. It should be 5. Right? 1.7 cancel, then it should be 5. Yeah, it should be 5. So we get up to s raised to 0. This equation starting from the highest order in the characteristics equation, s raised to 4, and we can end up to s raised to 0. Then you have to check whether the system is stable or not, right? For that, I'll mark it by the blue ink. Check this first column numbers. In this first column numbers, all the numbers are positive, right? All the numbers are positive. If all the numbers are positive, then the system is said to be stable. System here, first the point or the result be like, you have to write this result be like, the system is stable. Here, the system is stable. Then the second point is all the numbers are positive, right? Here the first number is 1, the second number is again 1, that's s square is 16, s raised to 1 is 1.7, and s raised to 0 is 5. That means all the numbers are positive. Then these roots are lying on the left half of S plane. Okay. This is one of the example for Hurwitz stability checking or for the stability checking method. I'll do another one question. You have to write all this. Okay. Here I write the question number 2. In this question, the same as the first one, using Routh criterion, determine the stability of the system represented by the characteristics equation. 9 s raised to 5 minus 20 s raised to 4 plus 10 s cube minus s square minus 9s minus 10 is equal to 0. First, you have to write the characteristics equation. 9 s raised to 5 minus 20 s raised to 4 plus 10 s cube minus s square minus 9s minus 10 is equal to 0. Clear? In this question, check what's the order of the system. Order of the system, the first number is s raised to 5. So the order of the system is 5, and it's gonna be the odd number. S raised to 5. 5 is an odd number. So we have to write all the odd numbers right here. The coefficient of s raised to 5 is 9. Then the next number should be s cube. The coefficient of s cube is 10. Then the next number is minus 10s. S raised to 1 is the next odd number. So minus 9. Then the next column, next row numbers are s raised to 4. We have to write it by a order. Okay. So descending order. So first row is s raised to 5. First row is s raised to 5. Then the next row is s raised to 4. 4 is an even number. So we have to write all the coefficients of even numbers in this characteristics equation. The first s raised to 4, coefficient of s raised to 4 is minus 20. Then the next one is s square is minus 1 and s raised to 0 is minus 10. Then the next step is the proceedings. In this, you have to check whether any row is divisible by any particular number. Okay, in this s raised to 5, we have 9, 10, minus 9, and 9 and 10 are not divisible by any one number, so we can't do that. Then s raised to 4 is again minus 21 and minus 10. 20 and 10 are divisible, but 1 is not divisible by 20. All these three numbers are not divisible by any one particular number, so we can do the reduction. And the next process is to find the s raised to 3. S raised to 3 will be the next descending number in this order for finding out the stability. So s cube is how to find it, like minus 20 into 10 minus 1 into 9. I have to write it here. I'll write it here. Minus 20 into 10 minus what? Minus 1 into 9 divided by this number, the column, the first number in the second column. Here we have to divide it by this number. So minus 20. Then we get it as minus 200 plus 9 divided by minus 20. Minus 200 plus 9 is 191. Minus 191 divided by minus 20. It should be the some kind of a positive value. That is 191 divided by 20. So we get it as 9.55. Okay, s raised to 3, the first column number in s raised to 3 is 9.55, or the coefficient of s raised to 3 by the calculation is 9.55. Then we have to do it by 20 into minus 20 into minus 9 minus 10 into 9 divided by again minus 20. It's be 2180. 20 into 9 minus 20 into minus 9 is 180 plus 890 divided by minus 20. It's 180, 270. 270 by 20 minus 13.5. Okay, minus 13.5. We have no other values right here, so we can proceed it by taking the s raised to 2 second power s square. That is again 9.55 into 9.55 into minus 1 minus 13.5 into 20 minus 13.5 into minus 20 divided by its 9.55, the first number in the column. Okay, the first number 9.55. That's minus 9.55 minus into minus is plus. That is 13.5 into 20 is 270 divided by 9.55. That is its minus 29.2. Then the next number is 9.55 into minus 10 divided by 9.55. Here we have the 0 value, no number there, so we can assign it as 0. Then 9.55 into minus 10 divided by minus 9.55 is again minus 10, right? Then s raised to 1. S raised to 1 is minus 29.2. It's again minus 29.2 into minus 13.5 minus 10 into 9.55 divided by minus 29.2. It's 394.2 minus 16.7. Okay, minus 16.7. Again, we have to find the last value as s raised to 0. S raised to 0 means minus 16.7 into minus 10 divided by minus 16.7. Again is minus 10. Okay, again it's minus 10. So we finished all the steps starting from s raised to 5 and the last one is s raised to 0 up to s raised to 0. Then we can check the stability. First you have to find it by checking the first column numbers. Numbers in this, all the numbers check. All the numbers in the first column, we have so many negative values and positive values. That means we have 2 positive values and 4 negative values. So the system is unstable. If occur any kind of negative values in the first column, then the system is said to be unstable. So the first result is system unstable. Okay, result system is unstable. The second point we write it as 2 roots are lying on the left half of S plane, they are the positive values, and the other 4 roots are lying on the right half of S plane, they are the negative values. Okay, finish. Then I'll do another question. Write it. Okay, check. Here I wrote the third question. Its characteristics equation is s raised to 7 plus 9 s raised to 6 plus 24 s raised to 5 plus 24 s raised to 4 plus 24 s cube plus 24 s square plus 23 s plus 15 is equal to 0. In this, the order of the system is s raised to 7 and its BD odd number. So I'll write the s raised to 7 and the coefficients of all the odd numbers in this characteristics equation. And s raised to 7 1, s raised to 5 has 24, and s raised to 4, s cube have 24, and s raised to 1 have 23. Then s raised to 6, the next descending number as s raised to 6. 6 it's be the even number, and all the coefficients of this odd number, all the coefficients of this even numbers are, first one is 9, the next one is 24, again it's 24, and the last one is 50. Then check any number in this 2 of this rows. Check any row is divisible by any one particular number. In this question, s raised to 7 has 1, 24, 24, 23. It's not divisible by any one particular number. But in the case of s raised to 6, or in the case of even number series, we have 9, 24, 24, 15, and all these numbers are divisible by 3. Okay, 3 threes are 9, 8 threes are 24, and 5 threes are 50. So we can divide, or we can reduce this s raised to 6 as s raised to 6 is equal to 3, 8, 8, and again it's 5. 5 threes are 50. Divide all these numbers by 3. Then we have to further proceed it with s raised to 7 and s raised to 6. So we don't have this line. Okay, you can cut this. Here s raised to 5. S raised to 5 means 3 into. Okay, check. I'll write all the values and the calculation. Here I get a halt here in the order s raised to 3, or all the values drop up to 0 in the case of in the order of s raised to 3. We didn't finish this step up to s raised to 3. We can check the stability by checking it by s raised to 0 at the power of s raised to 0. So for that, here we get the complete halt here, and in this step we can assign one auxiliary equation, or the auxiliary characteristics equation at the stage of s raised to 4. Okay, at the stage of s raised to 4, we make an auxiliary equation, and then further proceed that auxiliary equation. We want to check the stability, so we can assign the last number we obtained in the order of s raised to 4 is 1, 1, 1. So we make one characteristics equation, or we make one auxiliary equation representing s raised to 4 as s raised to 4 has 1, 1, 1. That means it has s raised to 4, s square, and s raised to 0. So I make one auxiliary equation in terms of this s raised to 4. 1 into s raised to 4 plus again 1 into s square plus 1. S raised to 0 means 1. And differentiate this a with respect to s at equal to 0. Then we get differentiate this auxiliary equation with respect to s. That means we get it as 4s cube plus 2s. Okay, 4s cube plus 2s. Then we have some, again we have one characteristics equation. It's of the order of s raised to 3. That means we can write this s raised to 3 as 4 and 2. 4s cube plus 2s raised to 1. 3 is an odd number, then the next number should be s raised to 1, that's 2. Coefficient of s raised to 1 is 2. So you can further proceed it with s cube as 4 and 2. Then s square. S square is like s cube and s raised to 4. 4 into 1 minus 2 into 1 divided by 4 is 4 minus 2 by 4. It's 1 by 2, it's 0.5. Okay, it's 0.5. Then 1 into 4 minus 1 into 0 by 4. 1 into 4 by 4, it's 1. Then s raised to 1 as, here I get it as minus 6. Then the last one is s raised to 0. S raised to 0 means what? Minus 6 into 1 divided by minus 6 is 1. Okay, 1. Then check for the stability of the system. In this question, we have only one negative number. Yes, we have only one negative number. Then the system is stable, unstable, or limitedly stable. Here,
I can say this as unstable system.
because we get a drop here in the place of s raised to 3, or in the place of the order s raised to 3, the order 3. So we can say this characteristics polynomial as
Unstable system.
then how many of them, how many of the roots are positive? That positive roots, all the positive roots are lying on the left half of S plane, and the negative root is lying on the right half of S plane.